Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
So in the previous videos, we have discussed about the sensors and all the capabilities of the new Arduino Nano 33 BLE, except the BLE. So that's what this video is about. In this video, I'm going to be teaching you how to use the onboard BLE to wirelessly send any data to your devices like your phone and your tablet. So let's get started. Hello everyone, welcome to RoboGrace. My name is Thomas, and this video is all about the BLE capability of the Arduino Nano BLE. So in case you missed our previous video covering the onboard sensors on the Arduino Nano 33, you can check those videos in the top right hand corner. But this video is solely about the BLE capability of the Arduino Nano. So what is BLE? BLE stands for Bluetooth Low Energy, which is a version of Bluetooth designed for extremely low-powered applications. In fact, the BLE radio can easily last up to a year on a small coin cell battery. BLE has a variety of applications in a variety of fields like health monitoring, IoT, and it's also there in smart tags like the recently announced Apple AirTags or the Tile Tracker. So in this video, I'm going to be teaching you how to make use of the BLE functionality of your Arduino Nano 33 to send the onboard sensor data to devices like your phone or tablet. So without further ado, let's get started. Before we get started with BLE, it is quite important to understand the exact working of the BLE protocol before we can start writing code to use it. There is a detailed write-up in the official Arduino website that you can go through. I will have the link of the website down in the description below. But for short, I will explain the very basics of the architecture so that you can get started with it. The BLE architecture is something like that is shown in the diagram on screen right now. The BLE device sorts of act like a notice board, and the notice board can have multiple notices called services. Each service can also have a subcategory called characteristic, which is sort of like an attribute for those services. So for example, we have the Nano 33 BLE as the device. So the peripheral device will basically be the device, and you can name it according to your application. The service can be the different kind of services that the Nano 33 sends. So for our example, we'll be only using one service, and in that one service, we can have subcategories called characteristics. For example, later in the tutorial, I'm going to be showing you how you can send the temperature data, the pressure data, and the magnetometer data from the Nano 33 BLE to your smartphone. So the peripheral device is our very own Nano 33 BLE, which I'm going to be calling the Arduino environment sensor. Since we are sending custom data, the predefined name for the service is custom service. And I am going to be adding three characteristics to it, namely the temperature, the pressure, and the magnetometer. To repeat, our peripheral device will be called Arduino environment sensor. Our service will be called custom service, and our characteristics will be having three, and for our particular example will be temperature, pressure, and magnetometer. So we need to take note of this so that we can implement it in our code. Now on to the coding part. I've already prepared the code, and the full code will be available in one of the links in the description below. Firstly, make sure you have all the libraries installed. I have covered all the required libraries that you will need to use the onboard sensor on the Nano in the first video of the series. But in addition to these, we also need one more library called Arduino BLE. You can open Tools, go to Manage Libraries, and search for Arduino BLE. Since I already have the Arduino BLE library installed, my install button is grayed out. But for you, you can click on the install button and restart Arduino IDE. Once installed, the first 4 lines are just importing the required libraries for the sketch. Then we initialize 3 global variables called P, T, and M.
P for pressure, T for temperature, and M for magnetometer. Line 10 to 16 is defining the parameters for the BLE service. So on line 10, we define the service name of the BLE. So BLE service name is predefined in the BLE specifications. And since our service is a custom service, we have to define it as custom service along with the unique identifier for passing along string data type. So just copy this line as it is for passing string data values. Line 14, 15, 16 is adding the characteristic to the particular service. So the syntax goes like this: BLE string characteristic, string because we are using string variables, the name of the characteristic, the unique identifier for the characteristic, the properties for the characteristics, and the data length of the characteristic. So for example, for pressure, I've named the variable as BLE underscore pressure. 2A56 is the unique identifier for sending that particular characteristic. BLE read pipe BLE notify is the property we are defining for that particular characteristic. So BLE read means the peripheral will only send the data when the central device, like your phone or tablet, requests for it. While BLE notify, on the other hand, is the function of BLE where the peripheral keeps sending data to the central device. So BLE notify is used for devices where the data keeps changing in real time, while BLE read is only for situations where the value does not change as often. 13 is just the character length for the data we are passing through the BLE. Void read values a prototype function declared here. We'll come to the function later on. And under the void setup function, we initialize all the sensors and the BLE device we require along with the serial terminal. In line 37, we set the name of the device when it shows up in the Bluetooth search results. So I've named my device as Arduino environment sensor. We are going to set the advertising parameter. So BLE.set advertise service as custom service. And we again have to add the characteristics, the 3 characteristics that we defined above, to this particular service using custom service.add characteristic and BLE pressure, temperature, and magnetic field. And then we are going to add the custom service to the BLE stack by using BLE.add service. Once all the setup is done, we run BLE.advertise to start advertising the Bluetooth device to the nearby Bluetooth receivers. And we print the same thing on the serial monitor. Under the void loop function, we have BLE device central equal to BLE.central. This returns whether a central device like your phone or tablet is connected to the Arduino Nano. If it is connected, the central variable will be true. If it's not connected, it will be false. If the central device is connected, that is what this condition is. So we print it on the serial monitor that the device is connected. We print the address of the device, and while it's connected, we run the function called read values. Read values is a simple function where we are reading all the data from the sensors. We put those sensor values into the global variables P, T, and M as I'd shown above. We'll come to this particular function later, but once we assign those sensor values to those global variables, we write those values to those characteristics that we defined above using a characteristic name .write value function. So BLE underscore pressure .write value bracket P. Similarly for temperature and similarly for magnetic. And we are also printing the same value in the serial monitors just so that we can compare the data. And we put a delay of 1 second. If the device gets disconnected, then it will stop running this particular if condition, and the serial monitor will just keep printing out that the central device is not connected to the Arduino. Under the read value function, we are just reading the sensor data from the Arduino Nano. If you want to know more about how these libraries and how to exactly read all these sensor data, you can check out my previous 2 videos covering the same topic. So just an overview on how this function works. We initialize float X, Y, and Z. This is for the magnetometer. We initialize pressure, and we read the pressure using barrow.read pressure. We initialize temperature, and we read temperature by running hts.read temperature. And for the magnetic field, we check if the magnetic field is available and use imu.readMagneticField and put those values into X, Y, and Z. Now we are using the global variables and we are formatting the data in such a way that it's user representable. So for this case, I am just adding the units for the particular values so that when you see the received data on your device, it makes more sense. So P is equal to string of pressure. We are converting float value to string plus kPa because the pressure is measured in kilopascals. Same for temperature. I'm adding space C for Celsius, and for magnetic field, I'm using X and Y. So that's it. Now all we have to do is just upload the code. To upload the code, take a Nano and double press on the onboard button to put it into programming mode. Then go to Tools, select the port, and upload the code. Once the code is uploaded, you have to go to Tools and select the COM port again. Open the serial monitor, and you will see right now that there is no central device connected to the Nano 33 BLE. So now I take my phone and I have this app called NRF Connect for mobile. Now this same app is also available for iOS devices, so you can use the same app on an iPhone or an iPad. I already have this app installed, so I'm just going to open the app. And under the scanner tab, I will just refresh. And you can see that there is a BLE device called Arduino environment sensor, the same as what we declared in the code. I'm going to connect to it and give it some time for it to load. And as you can see, the serial monitor has changed and it shows that a device is now connected, and it started printing out the sensor values on the serial monitor. We just give some time for the mobile to connect. And once you're on this tab, click on the unknown service and you will see three different outputs. You click on the 3 arrow, and this basically indicates to the device to continuously print the values to the central device. So I'm just going to click on this here and here. Now you can see the different values being printed under the different subheading. Ignore the subheading, you can modify it by clicking on it, but under the value you can see there's a hex value, comma, string that the device received. So as you can see, right now the pressure is 101.03 kilopascals, and the second output is 33.39 degrees Celsius, and the third output is the magnetic fields on the X and the Y axis. Now just to show that the sensor is in fact live, I can take a magnet and move it around the Arduino Nano, and as you can see, the magnetic field keeps changing. And once you're done with your data, you can click on the disconnect button and the Arduino Nano will go back to a disconnected state.
So the BLE capability, along with the efficiency with the technology, is what allows us tinkerers to make smart devices without worrying too much about the power and the battery life. And any device with the certification of Bluetooth 4.0 and above can easily receive and interpret the signals from a BLE device. So that's it for this video. Hope you all enjoyed the video. Subscribe to RoboGrace for more content like this. And until then, stay safe and have a good day.